How's it going, everyone? Eulier Gonzalez here, exploring the user input, scrolling, and listing. And this is something interesting because on the web, you assume a lot of the stuff that the browser is doing for you. For example, in scrolling and listing elements. So because here we are building is React Native applications, which is just a wrapper around React that help us to build user interface. But the thing here is React Native, since now is an architecture that help us or that target is a specific compiler native platforms, which is iOS, Android, and all that kind of stuff. This works by running these two processes. You have the fabric, which is the rendering systems that transform the idea of 0.73 React Native versions is to eliminate this async gap or async bridge. So now with this new rendering systems, which called fabric, they want to bring a lot of this logic to the render logic to the C++ directive binding, as well as improve performance and among other stuff. But the key point here is to this React rendering system called Fabric, which is the entire reason of the idea of this is just to target this specific compiler native most common user elements or user interface and functionalities. But because React Native, this React rendering system called Fabric has three phases similar to React. When you have now three phases on React, you have the trigger, render, and commit. But this is now how it works on the web. However, here on native mobile apps, you have now the render, of course, the commit, and mount. So this render is when now is React Native transform is the React element tree into the, which is in JavaScript, into the React element or the React shadow tree, which is now on reading in C++. And on the mount and on the commit phase is when it's going to calculate now the layout, which is the way of how indicate that this React shadow element or React shadow tree is a candidate for to be mounted. And here is now the layout calculation, where this element is going to be and all this kind of stuff. That particular process is handled on the browser by the reflow. So the browser has now the HTML and CSS, which transform that in. The browser has a process called the critical rendering path. The TLDR is that it transforms HTML, CSS, and JavaScript into pixel on the screen. And this is made of the DOM, the CSS OM, which is the way of how it, or which is what it parses when it parses the DOM, when it parses the HTML into DOM and the CSS into CSS object DOM, and then it merges that into the render tree, which contains now all the information needed to be displayed on. However, it doesn't know the browser the dimension and the position of these elements. And this is now handled by the reflow phase or the layout phase, where here is usually triggered by JavaScript code that pass now through the layout and then to the so what this is when it calculates the style, the layout, and the style, the layout, the okay, no, it's okay, it's good. Let me actually refresh that. because this is part of the front-end system design, right? Like this, which is part of the core fundamental, but particularly here on the browser rendering, here, the composition layer, CPU, but it's this one. So you have the style, the layout, paint and compose it, all right? And this is something that you can improve. In other words, is to, instead of using CPU, let's going to use now GPU, which is use some specific CSS class property that help you to, instead of calculating or modifying is the position or the dimension of these elements, you just only target or talk to the GPU phase, which is the paint and decompose. So for example, transform in the CSS. But the idea here is to understand that pretty much like the, let me actually bring this up so we can look at together the fabric, right? Exactly here, pretty much here. When it create this, when they say, hey, this promotes both the React Elements tree and the newly created shadow tree as the next tree to be mounted. So in that phase, on the React Native or the fabric, all right, it now is not only is promote this, and this is a particularly word that I would like to use. It promotes the React element tree, which is on JavaScript, and the React shadow tree, which is on C++, to be as the next tree to be mounted. And also it has calculated the layout information for this. And then on the mount phase is when it say, hey, let me transform is the React shadow tree into the host view tree. You might wonder, what in the F is this? Well, this is now the directive of that, the native directives instance. So for example, view group and text input and text view and all that kind of stuff. The size and location of each host view are based on the layout metric calculated with Yoga, which is calculated previously, you know, on the commit phase. And the style and content of each host view are based on information from the React shadow tree, right? The style and the content of each host are based on that information from the shadow tree. But again, at least understanding this, that is not required, but at some point when if you have worked with this technology, you need to understand that how the things work, the inner mechanism. And because this pipeline is, or may occur on different threads, and those threads are the UI threads, which is specifically for manipulating host views, and the JavaScript threads, where the React render happens, with the React render phase, as well as the layout are executed, right? And this is most commonly what happens on each different, this is on a pipeline, right? Which is, hey, I detect this change, let me render that, calculate this layout, commit, all of this can happen on the JavaScript phase, and then mount on the UI threads, or pass that information, communicate to the UI thread, which is exclusively for manipulating host view. So far so good, because with this threading model and understanding is how the fabric works and what React Native is at the end of the day, we use Expo because this is now allows to do all the stuff that are required in our React mobile hybrid development, which is not only to write user elements, but also how can we now deal with navigation and routing, and when it comes to publish your app, how you gonna do that? So Expo now, this is an open source library, framework, help us with that. And over the couple past videos, which is taught by Gary Kraman, shout out to Gary Kraman, man, absolutely. Which is, she worked as a director of engineering mobile in Formidable, and then now she is a software developer at Expo, which is good, which is a great stuff. Now, well, anyway, so the goal of this course is to build the shopping list and a reminder and a third blank page for experiment, right? So we went through understand that what is React Native, what is the value proposition, when React Native was born in 2013, who made this, Facebook, to actually close the gap between the web and the mobile development into one. So React Native is, from their website, is learn one, write everywhere. And then we look at how can we set up using Expo. So first, how we set up our environment using ESLint and Prettier, and shout out to ESLint and Prettier, because ESLint help you to fix common JavaScript problems, and I really love that. It might be quite, at the beginning, quite annoying to set up, but the value that you're gonna get from this is huge, if massive. So we also describe is here the fabric and the React rendering, which is a great stuff. And then how can we now actually is look at the dev tool from React Native, and how can we do that? And finally, how can we create our first components in React Native, which is, after all, is a JavaScript function, right? How we're starting to see the components and the stylings by creating our first React component screen, using some of the common directives like view and text. Also, that in React Native page you have is the style from the namespace style sheet, where you can define your specific styles. Here we're not using is unit, here using, or pixels, we're using is screen device unit that are different across different mobile experience or device hardware. So as a rule of thumb, this is something that is made by Gary Kraman, which is using is even numbers for anything related to positioning, all right? Whether it's padding, horizontal. Also describe that everything here on the screen is following the flex layout, by default a column, right? You can also modify that to show is row element, which is pretty cool. And then you can pass that to the particular style that you need to. Then, how can we now is create our components in a React Native, follow the reactivity development, but in this case the React development, by creating all of these components. Following is the atomic design, starting from the atoms and then the molecules and then the organism. Then you compose that into page. Then you have now your website using the component folder and define your files there. Also, you can pass dynamic data to this component, pretty much like React Native or like React application. And then, how can we deal with navigation? We don't dive deep too much into this, because we're gonna do that in the next course, which is the intermediate React Native. So the idea here is on the navigation. And this is to understand that what are the type of library that we can go with, React Navigation or the export router. So the subtle difference is export router is a file-based routing, pretty much like Next.js. When you define all of your routes inside of the app folders, and inside of those folders you have is specific files that you can define to help you cover most common use cases. Let's say the layout, the template, the error page, the 404, the loading, and then finally is the page. So it actually followed that similar convention, but here we use is the layout, the underscore layout for that. And the index to indicate that, hey, this is now our page, this is the route for our page, and this is what you're gonna load when you navigate to. So, because the navigation in mobile is quite different to the web, right? We have three types of navigation: the stack, the modal, and the tab. We explore a little bit of this, and we define those on the layout, which is quite interesting, because you say, hey, this is how this screen is going to look like for this page. Again, this is something quite different from the web, where on the web you can define, it's also as well as in the layout, hey, this will be how all of these components were going to look like. So it has, again, very narrow specific stuff to do. So we went through stack navigation, and then defining some models, how you can define some model into the stack. And then on the stack is when all of these different screens put on top together, right? And when you remove one, you can, or when you remove that, you go back to a particular navigation. You also can look at the navigation history on the left icon, usually, and also the tab navigation. So pretty straightly scripted. So actually there's nothing too much to explain that with the navigation, the nested navigation. There's some subtle nuances, especially if you want to now do some nested navigation. For example, you're going to put a stack into a tab navigation, and if you want to, for example, show the stack navigation inside of the tab and improve the area of your, to improve the user experience when you want to navigate to that, you can use this, some particularly convenient method from these native React applications. So for example, touchable screen or opacity and all that kind of stuff. So that was pretty enlightening in terms of how all of these things works. And actually you can write your own applications from the scratch, which is something that we went through. Now, also, we look at the input or the text, the scrolling, and the listing, and how these different sections now we give that by settle in web development. For example, in text input, we usually use form for that, but unlike here on the web, you have to define text input independently to be managed then. So for example, like this, right? It's not working, but actually showing now different stuff here, right? If we do this, what are you gonna do? Let's say, hey, let's want to add now is to milk, right? So milk, right? Also, we look at that the text input native controls the keyword. So when you do done here, we add that here. And this is what's going on when you define is your list, okay? We do that by using is scroll view or simple view, but unlike the web, where when the content is overflow, it actually now give you that behavior to that sort of list or that list of element. But here you have explicitly to tell to that. So we got now this navigation here. We also use the sticky header elements to say, hey, because all of these elements are rendering on the same position, which is inside of this scroll view, right? I want you to now stick this element. So they have a particular property to actually say, hey, this first element that is rendering, well, let's make it now sticky here, right? So another interesting thing is that if we add, for example, let's say I add milk, let's say tea. If I add tea, right, and I hit enter, exactly, it doesn't navigate back to the top of that, right? That'll be a good user experience. Also, we look at how you can add some icons here. One of the great things of using Expo is that it provides you the icons that you can go with out of the box. So that's great in terms of developing this kind of apps. And how you can pass the color to these particular tabs, part of the themes. Now, in talking about themes, we can go with native winds, but here we just implement is so native wind is like Tailwind for React Native, so this is it. And then, well, we also implement is the scrolling here. So this is our, so we look at the input, the scroll, and how you can define your scroll. And now on the list. So unlike the web, where you use is just simple JavaScript functions to render that. So here, there is a particular component that helps you to do that. And that's what we're going to do in today's video. And that is FlatList, right? Let's get into this.
So we've used a scroll view here, and we've mapped over an array of items to render things in a scroll view. Mm-hmm. And this is actually something that you shouldn't.
You got here. Where is it? There you go. History layout, counter, exactly. Scroll view. Let's go back here. And FlatList. So from the following code is not recommended. Okay. So from the following code, which is not recommended to use, okay. From the following code, is not recommended to use map functions. Exactly, and I get it. So from the following code, it's not recommended to use map functions to it's not recommended to use map functions to render a list of elements. Instead, use a scroll view, a flat list component. Why? Since flat list is rendering a flat list is rendering. Let's go to actually take a look. But flat list is rendering supporting the most handy features. If you need section support, use section list. A performant interface for rendering section list. For rendering section lists. Okay, that's interesting. But flat list is just for rendering lists of elements. Let me see if they actually describe this. To render multiple columns, use a num column prop using this approach instead of flex wrap. Layer can prevent conflict with item height logic. More complex selectable examples are like this. You can pass, and then also the key extraction, something that we're going to talk about that. But exactly, this is a convenience wrapper from virtualized lists, right? A virtualized list. Let's get into this. Okay. Let's get into this. So, base implementation for the more convenient flat list and section list components, which are also better documented. In general, this should only really be used if you need more flexibility than flat list provides, for use with immutable data instead of plain arrays. So virtualization massively improves memory consumption and performance of large lists by maintaining a finite render window of active items here. So it maintains a finite render window of active items and replacing all items outside of the render window with appropriate side blank space. So for example, if we render these elements here, so all of these elements are already there, and with the safe area view and virtualized list, you got is this. So the window adapts the scrolling behavior and items are rendered incrementally with low priority after running interactions if they are far from visible area, or with high priority, otherwise to minimize the potential of seeing blank space. Some caveats: internal state is not preserved when content scroll out. This is a pure component, which means there is no re-render if props are shallow equal. In order to constrain memory and enable smooth scrolling, content is rendering asynchronously off screen. That this means it's possible to scroll faster than the fill rate and momentarily see blank content. This is a trade-off that can be adjusted to suit the needs of each application. By default, the list looks for a key props or each item and use the React key. Alternative, you can provide custom key extractor prop. But again, the idea of this is, since flat list is not a specific use case from the virtualized list, which is a improve memory consumption Exactly. Virtualization massively improves memory consumption. That's quite interesting. And performance on large lists by maintaining a final render window of active items and replacing all items outside of the render window with appropriate. This is using a technique called the resize window. This is a programming technique, by the way. I think is sliding window. Okay, so sliding window technique is used for defining as a window to solve problem like this, but to solve problem efficiently based on continuous subset of elements. So hey, this subset of elements, this is what I'm going to show or render this. So let me actually ask Cloud to this and say, hey, it is safe to assume that virtualized list in React Native is using the sliding window technique. Yes, React Native virtualized list does use sliding window technique, also known as windowing, for effective rendering a large list. This is how it achieves good performance when handling potential infinite lists of items. The basic concept works like this. Instead of rendering all items at once, which is of course, if you have 10,000 of elements or 1,000 elements, you don't want to show them all of them at once. So you want to show is a subset of them, a window, and then swap up, or right, and replacing all items outside of the render window with appropriate side blank space. In this case, it's like, hey, all of the elements that are outside of the window, right, are now a side blank space. But this technique here is to say, hey, this is the elements that are going to show now, that are going to be visible, and the rest of items will hold them in memory. So instead of rendering all items at once, virtualized list only renders items that are currently visible in the viewport, plus some additional items above and below. This additional area is called the render window. So we're exploring this because as we look later to data structure and algorithm, this is something that we need at least to understand conceptually, so then we can now understand that by doing. But again, is this. So it has now a fixed. So it now have a fixed render window, which is it's going to display all of the elements. It's going to have elements that are going to be visible in the viewport, and also on the top and on the bottom, right? And this is the element that you're going to show. The rest of elements is going to be held in memory and then loaded as this scrolling. So as you scroll, items that move out of the render window are removed from the DOM. Or in this case, well, actually it's explaining is this. But as you move, or as you scroll, items that move out of the render window are removed from the DOM. So hey, is these elements is the items that move out the render windows are removed from the DOM? The new enters, or the new items entering the render windows are rendering, and the windows slide along with scroll position. That's quite interesting. So as you scroll, the items that move out the render window, the items that move out of the render window are removed. The new items entering to the new render windows are rendered, and then the window slides along with the scroll position. quite interesting. But this is the step. It's like if we detect that change, if we detect that scroll, that's going to remove the items on the top. If you scroll down, that's going to remove the item on the top, and then adding more elements at the bottom, and then it's scrolling there. And the scroll is up, then remove those elements from the bottom or out of the down, and then apply those new elements from the down here at the top, and then scroll. The main difference from basic sliding window implementation is that React Native version include optimizations like batch rendering to prevent frame drops, items recycling to reuse DOM nodes, configurable threshold for preloading content, built-in support for variable height items. Interesting. Okay, but the TLDR is that FlatList, and we get it. We absolutely get it, because we want to be as much as possible, efficient as much as possible. So this is slide window. So sliding window problems are problems in which a fixed or variable side window is moved through the data structure, typically an array or a string, to solve problem efficiently based on continuous subset of elements. This technique is used when you need to find subarray or substrings according to a given set of conditions. If you need to find subarray or substrings, interesting. Subarray or substring according to a given set of conditions. Okay. In our case, we're using this sliding window technique, but it's not to find elements. It's in fact is to replace elements outside of this sliding window and show them properly. But when you want to identify a subset of items here in an string or in a subarray, okay, in any case, there you got it. Yes. So in general, this should only really be used if you need more flexible than FlatList. But again, because FlatList is now a specific implementation of this virtualized list, which is a massive improvement of memory use and performance by only showing its render sections that contain the visible items from the viewport and those elements on the top and on the bottom. And this is quite interesting because instead of rendering those thousands of elements, you're going to only render that subset of visible elements and those that are not on the top and the bottom, known as the render section or the render window. Makes a lot of sense. So this FlatList, oh my god. Okay, since FlatList is FlatList. Okay, since we want to display, so since we have limited memory and want to be effective and efficient with FlatList, which is a specific implementation of the virtualized list, right? That is a technique to massively improve memory consumption, okay, memory consumption, consumption and performance by defining a render window to show by defining a render window for the visible area and a and a small set of elements on top and bottom, right? Okay, again, conceptually we understand that. Now in implementation, okay, this is something that goes beyond the scope of this course, but at least to understand conceptually is important here. So let's get into this.
Do in React Native. The scroll views are really handy for pages that you think might be longer than a device's screen.
So FlatList, you can say this is a use case. Use cases, like so. So FlatList can be useful for elements that you know that are longer. They are longer than the device screen, which is a lot of time.
But if you have an array of items that you map over to render, then you shouldn't just that you think might render things in a scroll view. And this is actually something that you shouldn't do in React Native. The scroll views are really handy for pages.
So scroll views are really handy. Really handy for elements that you know that are longer than the device screen. Okay. But when you need to map elements,
pages that you think might be longer than a device's screen. But if you have an array of items that you map over to render, then you shouldn't use a scroll view.
But for mapping, elements, that's right. But for mapping elements, you shouldn't. You should use, or you must use, FlatList. Okay. Or you might wanna use FlatList.
In fact, you should use another component called FlatList. So FlatList is a completely new component if you're coming from the web, so there is no equivalent in the web at all. And basically, a FlatList is a more optimized way of rendering large sets of items on the native platform. The reason it's optimized is that it actually tracks how much visible area you have on your page.
Okay, but the point of this is, it use a virtualized page, but it use a virtualized scroll, which is a huge, massively memory. Is a huge, massive improvement in memory consumption and performance by only render a list of elements in a visible area, and also a small subset on top and bottom. So This is interesting.
And it doesn't render items that are way outside of this visible.
And you may wonder, is like, hey, how that works, all right? Well, that actually go beyond the scope of this course. This is using some of these sliding window techniques. You might want to go and explore that, how the things
area,
work.
and will also unmount items that you've scrolled past. So let's import FlatList from React Native.
And
so to convert this into a
that with
FlatList, we'll do a FlatList at the top level, so this will completely replace our scroll view. And we'll pass in our array of items. So we'll use the data prop. So data is going to be our shopping list.
Exactly.
And then the other property this has is a render.
Okay. So this actually accepts these huge collections. You know, this flat list accepts these huge collections as the data. Hey, this is the render you're gonna virtualize.
Item
this is the list
function.
you're gonna virtualize.
So basically, for each of these shopping list items,
here.
you are giving the flat list instructions on how to render them. So this will be a function, and each of this shopping list items will be passed into the render item as an object. So there will be an object, and it's called item. So in each render item, so this will be props.item, or if you destruction it from here, it's item. And then we're going to return our shopping list item, and the name is going to be item.name. We don't need the key because FlatList actually handles the keys for you as well if your data has either an ID or a key. So if the data that you're passing in has an ID or a key, then those will be used automatically. If your data you're passing in doesn't have those, you would have to use this key extractor function to generate a unique ID for the data. But in our case, we don't need to do that because we have an ID.
But it's interesting that using this key as a way to do these optimizations behind the scenes. Similar when you are rendering elements here, and then you tell React, hey, because we want to keep track of all of these elements behind the scenes, and when those state change, all right, it makes a lot of sense to have a key for that.
So sticky header indices work with FlatList, so we can copy that over. And we can also copy over the style and the content container style. And I think that is it, so we can get rid of the scroll view. Oh, no we can't. We forgot about the text input. So the text input, so now we have a list of items with the shopping list.
But where do we put our text input?
So text input goes to the header of our list. And thankfully, with FlatList, we have a component for that. So there is a list header component. And I think it's a function where we can pass in our text input. And now we can get rid of our scroll view. Lovely. So functionally,
okay, let's get into this. Let me, in fact, actually save this. So git status here. All right. So we save that input scroll list. Okay. I think we add that. No, this is the input, text input, flat list. So we look at input scroll view. Oh my God, I love you. Scroll view. Okay. Right. If you want to render a large list of this, So using scroll view and the list view, right? A scroll view, then you say, or list view, right? Using list view for that. Okay. For larger, you say use case. For content, larger, yeah, for larger content. Exactly. For a fixed, larger, yeah, for a fixed small number of things, for a fixed small subset of items, for a fixed small subset of items. Pretty much like the tuple, you know, there's a lot difference between tuple and an array. So for a fixed small subset of items, like tuples in JavaScript, right? Like tuples in, let me put it here, tuples in JavaScript. Say JavaScript here. Tuples, whatever name it is. Let me bring this up. JavaScript duality here. Is duality here or is no? It's TypeScript. HTML version, which is tuple. I think is here. Programming TypeScript is all the files products. Typing arrays is essential of TypeScript. Is this one, right? Typing arrays. There you got it. Okay, cool. Let me put it the source here. Okay, use case for a fixed small subset of items like tuples in JavaScript. So array in JavaScript plays two roles: tuples and array. We say this, and then we want to add this. Okay. No, I want to actually show this split editor. Shit. Okay. Oh, but this is a split editor. What if I want to open this? Oh. There you got it. Okay, so I can split this. So I want to split this and then open up. Okay, and there you got it. So use case for a fixed small subset of items, array in just replace two rows, tuple and array. This is similar to tuples, where you can have any when you have a fix, and I want to quote this, when you have a fix length of element that each one of them can be of different type. Pretty much is that. Okay. So all the length of the array is fixed. The length generally don't have the same type. So this is similar to tuple. A fixed length of elements, generally of different types, right? Now with list view, the use cases is for large list of elements, for a huge collection of them. Exactly. Let me write this one. For large data set, it has data from a server. Okay. For larger data set, it has data from a server. Behind the scenes, it use behind the scene is use sliding window technique, okay, which keep tracks of visible elements, okay.
Rid of our scroll view. FlatList with the shopping list. You can also copy that because we have a key and then checked so to be from visible area. I will also unmount items that's on your page on the native platform. The reason it's optimized is that it actually tracks how much visible area you have on your page.
So which keep tracks the visible, which keep track the visible or the renders windows. Let me do this. Behind the scene, sliding window is used a sliding window technique. It keep tracks the visible area you have in your device, and
it doesn't render items.
and it doesn't render items way outside of the list, or way outside of the visible area. So it keeps tracks the visible area you have in your device, and it doesn't render items way outside of the visible area.
That are way outside this visible area. I will also unmount items.
And unmount items that are past scroll, that you have scrolled past, item that you have scrolled past, that you have scrolled past. Okay. So if you need to explain this in simple terms, right? The scroll view and the list view, that kind of stuff. It's for rendering large data sets. So behind the scenes is using this sliding window technique, which is a way of keep track is the visible area of your device, and it doesn't render items way outside of the visible area, and a mount item that you have scroll past.
That's you scrolled past.
So technically speaking, is now it defined as the render window, which is made of the visible area and items on the top, and a subset of items on the top and the bottom. Okay. So in other words, define a subset of. It's a subset of. Is made of. So the anatomy. Is made of visible area, and a subset of elements on top and bottom, right? So with that, right?
So let's
Okay.
see.
Let's
Those text
actually
input goes to the header.
define
We have a list of
is
items.
this flat list. So let's get into this. Particularly flat list. All right, so let's get into this. Flat list. Where we are? Okay, flat list. That's right. We're going to replace this, by the way, or create now a flat list component. This is the flat list from component from React Native. I don't know why it didn't import that. Okay, it imported that. And here, we want is to now is render this. So First is the data that we're gonna pass here, which is in our case the shopping list. This large data set. Then is the render item. Hey, how you wanna look? How it can be either a flat list item or this. Since here we're gonna pass is now a okay, the props here is the flat item props, and the content is deprecated. Okay, now you're gonna receive is this props only, not a context. Interesting. Okay, whether it's a props or exactly whether it's a prop or a function here that it contains is the info list render item info. Okay, and since here we're gonna receive is some of the data, this data can be is made of the index or the item. If in your data you're passing or you have any ID, it's gonna be use that ID to render all of these elements. But in our case, we want is the item here, which is the data that we want to render here, by saying, hey, I want you to now is render all of these elements here on the shopping list item, right? On the shopping list item. So this is the item that we're gonna pass to this, which is the item here. We don't need to render is a key because in our data set we already have an ID. If you don't, you need to use the key extractors and define the functions for each one of those elements. So now the flat list React Native components can keep track those elements and do some of these performance optimizations behind the scenes. But in our case, we are not going to use it. Okay. Then we want to now is indicate what is the sticky header. Okay, which is in our case is this one. This is our sticky header. It also have access to the style and the content container style. Okay, how this container from the scroll view is gonna look like, which is here. And then another function to actually show is the text input header, which is how you're gonna show that. So you have this list header component where inside of this you can define is this as a function or just a single component. Okay, so list header component, if you take a look at this, it say, hey, I accept is a React component type or a React element for that. So I just want is to now render this text input here like it is, and that's pretty much everything here. So if we run now this, say hey, npm expo npm expo star, right? Use port 8. Oh no, oh, it's running. Okay. Let me see if this is actually true. Unexpected syntax error. on style. No, that's right. Unexpected token. Okay, might be here. You got is this. List her component. That's right. Okay, that's right. Yes, I need to wrap this as it is. Okay, so now it will render as expected. Well, nothing has changed visually, but behind the scenes now we are tremendously improve the performance and memory consumption. Okay, so if we, for example, reload this, say let's go to reload this, there you got it. Hey, this is T, we add T to this.
With the shopping list, but where do we put our text input? So text input goes to the header of our list, and thankfully with FlatList we have a component for that. So there is a list header component, and I think it's a function.
No, it's not. It's a component.
Pass in our text input, and now we can get rid of our scroll view. Lovely. So functionally, this should look pretty much the same as it did before, but practically, it will be a much more optimized version. And actually, I had a good demo of this, but we don't have a very long list. How can I create a very long list?
I do.
Test data. Item. We're expecting. Sorry, numbers. So what I wanted to show you is if I just console log.
Oh, exactly. So let's go into actually create is now this 10,000 elements here. That's right. So if I now scroll to the render items here, and then I want to see say console log this, and then render the items. Is there any other property here that I can show here?
The item.
Yeah, I was going to show the item there. And then I'll return this. Return this. As you can see here, we're rendering is only a small subset of elements. Yep. So as we scroll here, why not? I'm rendering a shopping list, and shopping list is this one, initial data. Let me actually reload this. But as you can see now, it loads quite amount of elements here. 143 elements. and not the with 10,000 elements, you know. As you can see, it's going to render more elements there, and then mount those that are not part of the render window, and so on. You know? Holy moly. We can also now put an ID here. Or wrap this into another component to say, hey, this is a view, where this view is going to show this, and the text, and the text view, Why don't import text from React Native? That's right, you say, hey, I want to show is the ID, bro. See item.id here, and as you can see, here is all of this. But this is because we are scrolling this. Let me actually now reload this. Exactly. So now we are able to see is those elements here, and as we scroll this, now we're seeing that, hey, it render is the visible area is 77, but it renders 183 elements, so we have almost the double elements. So you have the visible area, you have almost twice elements below, on the bottom and below, okay? Or twice elements below and above. Okay. Yeah, you have twice elements below and above to that. That's very, very interesting. Very, very interesting. I think this is good to actually show you that. Yep, and I'm going to add that to the log. Say hey, readme and app.index.ts with a commit. Say, hey, git commit visualize flat list optimization in terminal. Okay, I think this is pretty dope to actually take a look at that. But we're not going to render those kind of elements. But the idea here is to see what's doing that render items for us. Especially, it's helpful to render that huge amount of elements here. So we don't need to render all of that. So if we reload this, exactly. So pretty much that. All right. Yeah, that's actually, yep. That'll be all, bro. Like,
enjoyed 100 more to our shopping list.
so this is now our test data, initial flat list.
And I'm going to make this into an implicit return. I think that's what I did in the code example. Lovely. So FlatList has a bunch of useful properties.
So it's gonna use this. You have initial list, but you can have this test list. All right, and then you initial list, which is the shopping list items collections, and here we're gonna define them as a collection of each one of them, like this. You have an ID. That will be 1 at the beginning, and then you have now a name. That'll be milk, right? And coffee, tea, and milk. That is number 3. That's right, no problem. I'm going to duplicate this right below here. This one. This is now coffee. So coffee, and this is 2. Say, hey, this is tea and milk. That's right. So this will be our initial list. Where now is just like this. All right. Good. Awesome.
And one thing it actually has is a list empty prop. So you can define something. So rather than doing, if shopping list.length is 0, then render something other which render the flat list, you can have something that's built into the flat list that renders this list empty component if the shopping list is empty. So let's do list empty component and make this into a view with some text. And let's say your shopping list is empty. Import these from React Native. And let's just give the view a style. So style, styles, list empty, container. List empty container.
Yeah, because I don't want you to execute that, because you're going to do that.
And in our style sheet, we'll create an object. And let's give it a justify content center and align item center. And a bit of a vertical margin. So margin, vertical, let's do 18. Lovely. Okay, so now we can actually get rid of our initial shopping list. So let's start with an empty array instead. And because my array is empty, I'm getting my your shopping list is empty, list empty placeholder. Add. And
because this is, you can define is this list empty container.
Styles, list empty.
Exactly. Okay, some of the convenient stuff that we can do here, like so, for example, is okay, in our flat list and say, hey, this is now the empty. No, it's not here. It's here. No, it's here. Empty. Okay. Well, I'm going to put this here. So list empty component. My question is that what is the type of this? Again, it's a component in React, like so. You say, hey, well, I want to now is show a view from React Native. That's right. I'm gonna create now a view, which is pretty much like a div, and then right below the text from React Native, here we're gonna show is now your shopping list is empty. So your shopping list is empty. Okay. And this is what we want to show. We can say is now the initial list is empty. And right, wait, what? It seems like we add something here. We don't want to, which is this one. All right, and this is just to illustrate that now how that actually shows. So we want to give some style here. We say, hey, I want to now show this by defining here a empty list style
Container.
or list empty. Say list empty container. List empty container as it is. Then you say, since everything is a flex, you can say, hey, justify content center, right? And go to say, how do I say go to? Let me actually do this. It's like go to. How to go to in VS Code keyboard shortcut. Go to okay, Shift F2. Okay, thanks. Shift. No. It's like go to line. Okay. It's control go. Makes sense. All right. So here we're going to define is this style of the style dot list empty container. Navigate to that line 80 approximately 85. That's right. And then well, this must be, of course, is a string. That's right. And voila. Oh. List empty container. Oh, because this must be a flex one. No, that doesn't work. Okay. Style list empty container. Justify content. So this is align items center. So align items is vertical. Aligns. Okay. Let me actually take a look at the flex right now. Flex CSS layout calculation, so I can understand that what it means and all that kind of stuff. Okay, Flexbox layout guideline. Okay, on Flexbox you have now the container, the items, okay, the flex direction, the flex grow, but the flex and the items. So if you say flex wrap, flex flow, justify content is the container, which is something that you're supposed to work with, and not align self. It's quite interesting. Align self. Aligns items. Okay. Aligns all of the items on the cross axis. Align the items on the okay. Align the items on the cross axis. Okay, the cross axis and on the main axis. Exactly. The main axis and the cross axis. Okay. Yeah, again, get yourself familiar with this concept. So justified context is on the main axis, all right, elements here in this flex, which is supposed to work. Here, you just put content element here, and when you say align items, it's actually center that. So inside of this, you only have is one item that is now aligned is vertically.
List empty containers, and and align item center, and a bit of a vertical margin. So margin.
That's okay. Okay, there's a very interesting nuance here to go over here. Let's go over this, because here you're saying, hey, I want you to align is items on the main axis, which to me is quite fucked up. Is this supposed to work? Hey, I want to align items here on the main axis. No, this is not how it works. This is not how it works. I want you to now align items here in the main here in the cross axis. Think of this justified content version of the cross axis, perpendicular to the main axis. So this align items is on here on the cross axis, which is pretty fucked up. This is on the cross axis. Okay, align items here on the cross axis, and then justify content. Where now justify content, you say, hey, align elements on the main axis. Align elements on the main axis. Align content star and align items. And then align items center. And then you got this. Your shopping list is empty. We can add some padding here. Say padding vertical of 12, right? You have that kind of stuff.
Vertical, let's do 18. Lovely. Okay, so now we can actually get rid of our initial shopping list. So let's start with an empty array instead.
18.
And because my array is empty, I'm getting my your shopping list is empty, list empty placeholder. I know what I've done wrong. So I've mistakenly, in this list header component, I've put the text input into a function. So
so now, if I want to add this, say, hey, this is coffee. Now it add that properly. Property center doesn't exist. No, exactly it is. And then we got it. So if you wrap this into a function, is now render is the list header with the new value there.
Every time I change it, it actually re-renders it, which means that the text, the keyboard disappears. Pretty sure that is it. So let me just remove this function. There we go. That was the problem. So now if I do my keyboard, and now, yeah, there we go. There we go. And we have our coffee in our shopping list.
Okay, that was quite interesting. That was quite interesting. Okay, test list empty component. All right. So you have this one. Get push origin input scrolling list. There you got it. All right. Testing input, scrolling, and list components and functions and functionality. Yep. Mhm. Mhm. Using FlatList and without FlatList. And using FlatList. All right. And that'll be all for this video. Take care.